Hey everybody, and welcome to Algo Expert. In this video, we will be going over the best seat problem. So in this problem, we are trying to find the best seat to sit in, or the seat that is going to give us the most space in a row of seats. So that row of seats is going to be represented as an array, so like this array here, with ones being seats that are currently occupied, and zeros being seats that are not occupied. And again, we want to find the seat that is going to give us the most amount of space. Additionally, we want the space to be evenly distributed on either side of us. And we are going to return the index of that seat. We are also told that the first seat and the last seat in the row will always be occupied. And if there is no seat for us to choose, then we can return -1. And if there are multiple choices that would give us the same amount of space, we want to return the first option, or the lower index. So looking at this example here, which of the open seats would give us the most space? Well, we could sit here, but this gives us no space on either side of us, because if we sat at index 1, there would be somebody next to us at index 0 and at index 2. We can also sit at index 3, so we could sit right here, and to the left of us, we would have somebody sitting next to us, but on the right, we would have 2 open spaces. So this gives us more space than before, but it's not really evenly distributed because we still have somebody to the left of us. However, if we sat at index 4, then we would have an empty space to the left and to the right of us, which is exactly what we want. So this would be our solution, because this would give us the most possible space, and it is evenly distributed on either side of us. We could have also chosen index 5, but again, this gives us the same amount of space, but it's not evenly distributed, because we have somebody sitting directly to the right of us. So in this example problem, we would return the index of this seat, which is 4. Okay, so to approach this problem, we need to think about it in terms of what it's actually asking us to do. And in this problem, what actually matters is how many zeros are in a row. If we can find the spot in the array with the most consecutive zeros, that is going to be the space that we want to sit in, and we always want to sit in the middle of that space. So we want to sit in the space that is going to have the most space on either side of us, which is going to be the longest contiguous subarray of all zeros and the middle of that subarray. So in this case, there are 2 contiguous subarrays of all zeros. There's this first one at index 1 that just has a length of 1, and then there's this other one with a length of 3 going from index 3 to 5. So if we could identify this, we could just look to see which of these subarrays is the largest, and we can choose to sit in the middle of that subarray. Okay, so what I'm going to do is first of all erase this solution here, and what we're going to do is iterate through this array, and we want to keep track of the best seat we have found so far and how much space that seat has, and then we can just keep looking for more of these contiguous subarrays and update our best seat if we find a subarray of a larger length than the largest one we had seen up to that point. So we can say initially we have a best seat, and best seat is initially going to be -1 because currently we have not found any seat that we can actually sit in. And then we can also keep track of how much space this seat gives us. So we can say we have a max space, and we will set this initially to be 0, and we will update this once we find a seat that we can actually sit in. Okay, so now what we need to do is we need to find the first subarray of zeros. And what we're actually going to do is we're going to have 2 pointers, a left pointer and a right pointer. And the goal is going to be to get the left pointer to be the element before that subarray, and the right pointer to be the element after that subarray. And then we would have all of the space in between those 2 pointers be zeros. Okay, so to begin with, let's put the left pointer on the first element, and we can just go ahead and put the right pointer on the element after that. And now what I want to do is just continue moving the right pointer to the right until we hit a 1. So currently we are at a 0, so we can go ahead and move this pointer over, and now we are at a 1, so we would go ahead and stop. So now what we have is 2 pointers both pointing at a 1, and we can calculate how much available space there is. So the available space we have would be the index of our right pointer, which is going to be 2, and we can subtract from it the index of the left pointer, which is 0. So we can say we have 2 minus 0, And then we would of course need to also subtract 1 from that value to get the exact amount of available space. So 2 minus 0 minus 1 is of course going to be 1. So our current max space can now be set equal to 1. And then the best seat is the index between the 2 pointers. So that is 2 plus 0, and then we need to divide by 2. So of course that is going to be 1. So the index of the best seat is now 1. And now we can continue. So what we're going to do is we're going to move the left pointer to be equal to the current position of the right pointer. So we can take this left pointer and just move it to where the right pointer currently is, and then we can go ahead and start iterating with the right pointer again. So we can move it to the right, and now we are at a 0, and when we are at a 0, we just continue, so we iterate again. We are still at a 0, so we can keep going. We iterate again. We are once again at a 0, so again, we keep going. Now we are at a 1, and now because we reached a 1, we stop iterating. And I will also take our left pointer and just center it a little bit better so it's easier to see what's going on. And now again, we can calculate the max space. So the right pointer is at index 6, and the left pointer is at index 2. So the amount of space that we have is going to be 6 minus 2 minus 1. So that is, of course, going to be equal to 3, which again makes sense because we have 3 zeros here. And 3 is greater than the max space we had previously seen. So we can update our max space to now be 3. And now the best seat will be the middle index. So that is 6 plus 2 divided by 2. So that is 8 divided by 2, which of course equals 4. And again, this makes sense because index 4 is this index here, which is the middle of these zeros. So we can update the best seat to now be 4. Okay, so now we would continue iterating. So we would take the left pointer and put it to where the right pointer currently is, and the right pointer would keep iterating until it finds another 1, but in this case we just get to the end of the array, so because we are at the end of the array, we cannot do anything more. There's nothing more to find, there's no more seats to look at, so we can just return the best seat we have already found, which of course is going to be 4. And now I do want to look at one more example to show a bit of an edge case of how this can still work when we have a lot of 1s, so a lot of the seats are already filled. So here I have reset the best seat to once again be -1 and the max space to be 0, and we have this new array here. So we can start with the left pointer at the very beginning and the right pointer at index 1. And now the next step is to iterate with this right pointer until we get to a 1, but we are already at a 1. So what this means is that there's no iteration to do. So what we're going to do is calculate the max space we currently have. So the max space is going to be index 1 minus index 0 minus 1, which is going to give us 0, which is the same as the default max space of 0. So essentially this means that there is no space here and we can just keep going. So to keep going, we take the left pointer and move it to where the right pointer currently is, and then we take the right pointer and we start iterating. So we would iterate, and now once again we have reached a 1. So because we have reached a 1, we stop, and again we would calculate the max space. So max space here would be 2 minus 1 minus 1 for index 2 minus index 1 minus 1, which is going to be 0 once again, which again is the same as the existing max space, meaning we have no space here. So again, we would just continue. So now to continue, we take the left pointer, we move it to where the right pointer is, and then we move the right pointer 1 over. And from here, we would start iterating. So the right pointer now is actually at a 0, so we would continue, and now we have a 1. So now we would calculate max space once again. So that is going to be 4 minus 2 minus 1, which of course will be 1, which is larger than the existing max space of 0. So we can update this max space to be 1. And now the best seat will be 2 for the left index plus 4 for the right index divided by 2. So that is 6 divided by 2, which equals 3, which is this index here where the 0 is. So best seat is now 3. And now we would, once again, just continue. So we move the left pointer over to where the right pointer currently is, and then we move the right pointer over 1, and again we've reached another 1. So here we would again calculate that max space, and the max space would again become 0 because there is no space between these two indices. So we would continue, so the left moves to where the right is, and the right would move over 1, and now the right pointer is out of bounds for the array, so we know we can stop, and at this point, we can simply return our best seat, which was 3, which is this index here of the only empty seat. Okay, so that'll do it for this solution. So this is going to run in big O of in time, where in is going to be the length of the array because we iterate through the entire array, and we do this just one time. And then we have big O of 1 space, so we take up constant space because the amount of extra space we need for this solution is not going to scale in any way with the size of the input, whereas the time complexity is going to scale with the input size. And that's going to do it for the conceptual overview of this problem, but now let's move to the code editor for a code walkthrough. Okay, so now we are here in the code editor. We have our best seat function, and it takes in our seats array. So to begin with, we need to keep track of our best seat variable. So we can start by saying best seat is going to be equal to -1, and then we also need to keep track of the max space. So max space is going to be equal to 0 initially, because we have no space, and we do not currently have a seat. And now we need to first of all create the left pointer, so left is going to be equal to 0 for the index of the first seat, and then we want to have a while loop that is just going to continue to iterate until left is at the end of seats. So we can say while left is less than the length of seats. And while this is the case, we start by putting the right pointer to be left plus 1. So we can say right is going to equal left plus 1. And then what we want to do is we want to continue iterating with right until we don't see a 0. So we can say while right is less than the length of seats to make sure that we do not go over the bounds of the array. And while the seats at right is currently a 0, we will simply continue iterating, so we can say right plus equals 1. And now what we have is a left pointer and a right pointer that are both pointing to 1s on either side of a contiguous array of 0s, or potentially they're just two 1s that are right next to each other. But we need to calculate how much space we actually have here, so we can say the available space is going to be equal to right minus left, and then we need to offset this by 1, so we can subtract 1 as well. And now, if this available space is more than max space, then we have found a seat that is better to sit at than anything we have seen in the past. So we can say if available space is greater than the max space, then we want to sit in the middle of this available space, or at least that is our current choice. So we can say the best seat is now going to be equal to, and we want to add left and right, but then we need to divide by 2, and we will do integer division. So in Python, the double division sign is going to round down, which is what we want. So we make sure that we get an integer, and if there were two possible middle seats, we want to bias towards the lower index. And then we can update max space as well. So max space is going to be equal to the available space. And now we just want to continue iterating, so we update the left pointer to be equal to the right. So we can say left is now going to equal right, and this would just continue iterating. So in the next iteration, we then update right to be the index 1 after left. And then once this while loop completes, all we need to do is simply return the best seat, which is going to be our solution. And now again, this function is going to run in big O of n time. So we will have big O of n time. And again, n is going to be the number of seats, so the length of that seats array. And then we will use big O of 1 space because we only use constant extra space. So there's no space being used that scales with the size of seats. And the big O of n time is because of this while loop here. And it might seem like we have nested while loops, which we do, but this is still just big O of n. And an easy way to think about this is to look at the edge cases. So for example, if we had all zeros, then this inner while loop would have looped all the way to the end, and then after that we would just update left to be right, so the outer while loop would only have done a constant number of iterations. And then if we had all ones, we would actually just never get into this while loop at all, and all we would do is set right to be left plus 1, we would check available space, which would end up always being 0, and then we would just update left to be right. So essentially we would just iterate through the entire array one time, never updating best seat or max space, and then just returning best seat. So with those edge cases in mind, we can see that this updating left to be right and then iterating right one at a time is essentially going to mean that we just iterate through the entire array a single time. So that gives us that big O of n runtime. And with that, that will be the end of this solution and this video. I hope you found this helpful, and I'll see you in the next one.